Okay, the question asked by the student, an AC source producing EMF, E equals to E naught. It has two terms, cos 100 pi per second t and cos 500 pi per second t. Is connected in series with a capacitor and resistor RC circuit. The steady state current in the circuit is found to be I equals to I1 cos 100 pi per second t plus phi 1, the phase difference, and I2 cos 500 per second t plus phi 2, the phase difference. Now the current has two elements, one has I1 and I2 as peak value. Now options are I1 is greater than I2, I1 equal to I2 and I1 less than I2, and last option is insufficient information to compare I1 and I2. Let's move to the solving part. So this is an RC circuit. Let's say that E has some peak value E naught, and let's see it is sine or cos, anything can be written. Let's say sine omega t. So the current will be I equals to I naught and sine omega t plus certain phi phase difference we will include. Let's say that there is, we know that current and voltage has certain phi phase difference. So what is the relation? We'll only talk about I naught now, the peak value of current we are concerned about. So we'll talk about I naught. So what is I naught? So when we talk about I naught, so we have to know that I naught is equals to simply E naught by impedance. And what is impedance? Impedance is root of R square plus X square, and here X is Xc. So Xc is 1 by omega c. Now if you see, omega is varying here, so if omega will increase, what will happen? X will decrease, and what will happen? Z2 will decrease, and what will happen? Current will increase. So which omega is higher? For that the current will be, peak value will be higher. So it is a direct question of omega, so we can compare this and directly write that. So here if you see, so here it is 500, so what is omega 2? That is 500 pi, and what is omega 1, which is 100 pi. So it is clear that omega 2 is greater than omega 1. It implies that I2 is greater than I1. So it should be this third option. So that's the correct answer.